In this video, you will enhance your existing program to detect and store data for two lines. To follow along with this lesson, you will need a second black line some distance after the first black line. Let's start with the program we created in the previous lesson. Remember from the previous lesson that functions allow you to reuse a set of actions in a program. Every time the function is called, any code inside of the function is executed once. Let's modify our program to call the forward one-line function multiple times. First, since we'll be storing two lines worth of data, we'll need to create another variable to store the second line's distance. At the top of your program, add int, encoder line 2. In task main, we are currently driving forward until a line is detected, stopping the robot, and storing the distance to the line into a variable. To detect the second line, you can use the same behavior. Add the following to your program: forward one line, a set of parentheses, and a semicolon. Encoder line 2, equal sign, get motor encoder, parentheses, left motor, close parentheses, semicolon. Save the program as detectTwoLines. Download your program, but keep your robot connected to the computer when you run it. Place your robot on the light-colored surface, facing the black lines, and then press the Start button on the Program Debug window. The robot moves forward, detects the line, comes to a stop, and doesn't move again. Take a look at the Global Variables Debugger window. Notice how both variables have the same value? The issue is that the forward one-line function only moves the robot forward until it detects a dark surface. The condition in the first function call is met when the robot reaches the line, and the condition in the second call is met almost immediately by the first line. To solve this issue, we need to tell the robot to move until it doesn't see a line first, and then move forward until it detects the line. Let's enhance the existing forward one-line function to add a wait for not dark behavior at the beginning. Because wait for not dark is very similar to wait for dark, we can simply copy and paste our existing behavior as a start. Select the code inside of the forward one-line function. Right-click and select Copy. Add a few blank lines at the top of the function. Right-click and select Paste. Great. Now we need to modify the condition in the wait until to say, wait until the color sensor doesn't see black. To do this, we only need to change the Boolean operator of the wait until condition. The less than operator compares two values to see if the left side is less than the right side of the equation. Once the grayscale value is less than the provided threshold, 320 in this example, the wait until statement will allow the program to continue. To change this behavior to wait until the color sensor doesn't see a dark line, change the Boolean operator to greater than symbol. This last enhancement isn't required, but is good practice to visualize the program flow of our longer function. In between the two behaviors, add a sleep command. Sleep, parentheses, 1000, close parentheses, semicolon. The sleep command will add a small delay between the transition from dark lines to light surfaces. Save and download the program, but keep your robot connected to the computer. Place your robot on the light-colored surface, facing the black lines, and then press the Start button on the Program Debug window. Great. The robot moves forward, detects the line, and comes to a stop. But this time, it should move past the first line, briefly stop, and then move to the second line before stopping. Notice in the Global Variables window that both variables now have different values, representing the distances to the two lines. In this lesson, you learned how to detect two different lines and store the distance values for each with the help of a function.